Good afternoon, everyone. Welcome back to the Finding Genius video series. I'm here with Delian. Delian's a principal with Founders Fund, but more importantly, a co-founder of Varda Space Industries, which we'll be spending more time talking about today. Delian, thanks for joining us.
Thanks for having me on, and excited to chat about Varda today.
So could you before we get into Varda, talk a bit more about your background? I know you're from Bulgaria, you went to MIT, you had a health tech startup before this. We're at Khosla, so you've been around for a while. Could you go into some of that and just tell us a bit more about how you went into Founders Fund?
Grew up in a very Eastern European Bulgarian household. Both my parents have PhDs. Ended up growing up on a Caltech's campus, since that's where they both did their PhD. And so I always thought that I was going to be kind of an academic type. I thought I was going to do math at first, but realized that I wanted to do something better than my dad did, and he was an IMO gold medalist. And so I didn't feel like I could quite reach that as a mathematician. Yeah. So I decided to get into the world of sort of robotics, hardware, space, and so thought that I was going to eventually just become the sort of academic equivalent of my dad, but in the space world, I work at JPL. And then freshman year at MIT, ended up sort of taking a hard left turn, started to discover the world of startups, entrepreneurship. Ended up doing an internship at Square back in summer of 2012. That was the sort of summer between my freshman and sophomore year. I ended up just totally falling in love and realized that I needed to get out to Silicon Valley basically as fast as possible. And so ended up being roommates with a guy that was friends with the Teal Fellow, and so learned about that program. And so applied for the Teal Fellowship the winter of basically my sophomore year, and ended up basically dropping out after my sophomore year at MIT to basically start working on my company. Got the Teal Fellowship, ended up running that company for about 3.5, 4 years. We did it okay, not amazing. I think got to our peak month was around 15K MRR, roughly there. Not zero.
Before you go into that, what did you write in your fellowship application to get in?
It was, back then it was a little bit more of fund the person rather than fund the company or idea, basically. Right. I kind of pitched them on just hey, I'm Delian, here's kind of my background, and then I want to do something in the world of healthcare plus startups, and here are a couple of different ideas that I have. At the time, the idea was more around medication adherence and reminders around that, and trying to create some some smart hardware around that. But, a lot of it was just hey, I've worked at Square, I know how startups work, here are the connections that I've made, I'm excited to drop out, I'm dropping out either way, and so I think you guys should be along for the ride. And so, that was kind of it, and I had a kind of funny presentation in front of the whole, you do sort of get invited out for this interview weekend, and you do a presentation in front of all the previous Teal Fellows. A handful of the Teal Fellows, including some that now run sort of large unicorn companies that I'm since friends with, came up to me afterwards and said, hey, that was a fucking terrible presentation. You're not going to be a Teal Fellow. But it turns out they ended up being wrong. So, nice. It turned out to, get the Teal Fellowship and now friends with some of those guys. But yeah, it was definitely, that interview process has changed a lot since I did it, and it was definitely a little crazy.
Nice. So you were working on the company.
Yeah, so I ended up dropping out to sort of work on this company. We ended up pivoting sort of from medication adherence to being this kind of autism therapy EMR or workflow tool. So we sort of sold to small clinics that had, let's say, 3 to 5 clinicians, 35 to 50 patients. We ended up sort of, going through Y Combinator, raising a $600,000 seed round. Building out sort of a team. We, got to kind of ramen profitability, enough to pay for almost me and my co-founders, sort of rent and salaries and stuff, but sort of wasn't enough to really go off and raise Series A. Have a whole long tail about sort of all the things that I did wrong as a, 19 and 20-year-old MIT dropout trying to sell into enterprise healthcare systems. Turns out not the perfect sort of skill set and personality fit for that problem. But a lot of ways that I would have done it differently now, and I think I could, do it much more successfully now. But yeah, after about 3.5, 4 years of that, I was kind of getting a little bit burnt out. The company was kind of flatlining, and so I ended up joining this company, Teespring, as the VP of Growth. The way that I sort of got hooked into that was Keith Rabois, who had been a COO at Square when I was there when I was an intern, had then convinced him to angel invest in my company, was on the board of Teespring, and so as I started debating, what to do next after the company, he kind of convinced me hey, here's a great opportunity of Teespring at the time was sort of a Titanic, they had gone from sort of the hottest company in Silicon Valley to, just consistently declining revenues and, quickly running out of runway, and so was invited to, come in to partake as a part of kind of the rescue crew, and so because that, a 22-year-old sort of failed one-time founder, got the title of VP of growth, while I was there. And so was there for about a year, was ready to kind of start a company again, had a couple of different ideas. One of them was around the sort of cybersecurity insurance space that I kind of debated doing with the now founders of Newfront Insurance, Spike and Gordon. They ended up, wanting to go do something like Newfront, and I wasn't maybe as enthusiastic about that. I was pretty focused on this cybersecurity insurance idea. And so as that sort of founding team kind of fell apart, I went to Keith and was like, hey, what do you think I should do? Who should I co-found this with? And he ended up sort of convincing me that I should instead come work with him at Khosla Ventures for a year and use that as a way to sort of learn a little bit about venture, maybe do a little bit kind of EIR type program, start a company, and would have a much sort of better launch off point, from there, as opposed to trying to do it entirely on my own. And so I was like, that sounds interesting. And I ended up, maybe 6 or 7 months in, kind of getting hooked into the world of venture, just kind of realizing my personality and sort of skill sets and attributes were much a better fit for being an investor than they were for being a founder. I'm super ADD, intellectually curious, jumping all over the place, context switching. As an investor, those are all huge pros. As a founder, those are all huge cons. And so I tend to believe in just lean into your strengths rather than trying to mitigate, let's say, your weaknesses. And then most importantly, this eventually kind of leads to Varda. Realized that I could have a much shorter term or shorter time frame impact on the commercial space industry. I used to think that in order to work in space, you had to become rich in normal tech, and then you could work on space stuff. Versus in sort of month 6 or 7 at Khosla Ventures, I ended up meeting this commercial space company at Koch Systems that does sort of GAN on diamond satellite radios, bringing them to Vinod. Vinod being excited enough that he wanted to invest, and actually helping basically lead that seed round. And so I sort of had this aha moment where I was like, damn, I can be better at investing than I can at being a founder, and then also I can now do the space stuff, which is what I've always wanted to do in the long term, and now I can do it today. And so I tend to believe in sort of shortcutting to, whatever you'd like to do in your career earlier rather than later. And so started to get to know the world of the world of commercial space investing, and over the course of the following 4 years, ended up switching over to Founders Fund, mostly because Keith was getting recruited by Peter Thiel to sort of lead the early stage arm, and Keith was like, hey, I really like working with this guy Delian. If you want to recruit me, you got to bring him along as a package deal. Little did the Founders Fund guys know what they're getting themselves into, but I think it's turned out okay so far, and have continued to sort of focus on commercial space since then. I've led a handful of rounds, double down on a Koch Systems here from Founders Fund. Right. More recently, did this small sat propulsion company called MagDrive, and then obviously most importantly, sort of incubating, co-founding, Varda as a part of that. And I'm thankful, that's part of the thesis or excitement around joining Founders Fund originally was we like to do incubations here, and especially in these sort of deep tech areas. And so was excited. That was partially why I was excited to join, was to eventually have the opportunity to do something like Varda.
And you recruited Will, I don't know if I'm pronouncing his last name correctly, Brewy, to be the CEO of Varda. Could you talk a little bit about Founders Fund's interactions with SpaceX and how you were able to recruit him and why him to lead that operation for the company you were incubating? Before we get into what Varda does.
Yeah, Founders Fund is one of the earliest backers of SpaceX. I believe one of the largest shareholders. How even continued to be extremely bullish on SpaceX, especially with the progress of Starlink. So Will had actually already left, decided to leave SpaceX, several years ago, with some of his sort of own entrepreneurial ambitions. He started a sort of aerospace consulting shop, is kind of how to describe it. And then after that, actually briefly went back to SpaceX and then left again to actually go ahead into finance and try to learn about what he called, the quote unquote business world. And so, definitely, bullish enough on SpaceX that we're not trying to, sort of rip people from there, since we're, very happy with our investment and bullish on the company. But, Will was sort of already starting to think about how to leave the world of finance and actually now finally start the startup. And that was sort of always his long-term goal. He was going to do some stuff that was actually unrelated to space. He was just going to apply his engineering skills. But thankfully, I had a fraternity brother, very luckily, that was my same year at MIT, that ended up going straight to SpaceX out of school in 2015, and then since then has really done a phenomenal job there, has sort of risen through the ranks. He actually now works in the Starship project and reports to the VP of Starship, so he's sort of skip level to Elon on Elon's most important project, get yelled at by Elon on a weekly basis. My favorite question that he relayed to me recently was Elon asking him if there was a bomb strapped to your head that no matter what was going to explode in 6 months if Starship isn't in orbit, what decisions would you make differently? And so, I like it when, kind of hear those kind of inside stories of like how Elon really likes to push his engineers. But anyways, so I thankfully, like very luckily, had this fraternity brother that has extremely high credibility within SpaceX because of the work that he's done. And so I kind of went to him and I was like, hey, I know you're a badass. Introduce me to a badass that can be the CEO of this company that I want to start, and I'm not going to be able to find them on my own. Like, I can't go as a VC and be like, I need a technical co-founder for this company. It's just like, that'd be sort of doomed to fail. And so I made sure to start with him, and then, he basically introduced me to Will. We met like last week of August. I think it's now, roughly day 161, 162. And so we've gone pretty quickly from literally, cold email introduction straight to founding a company. But thankfully, sort of got along maybe a lot better than expected, and they just both think really similarly, let's say, about the world, but actually have very sort of different skill sets, personalities, et cetera, that actually like mesh together.
And what was
well.
I mean, it sounds like you have a pretty technical background too. So what sort of skills were you trying to supplement by bringing in Will?
Yeah, I am a former I'm a former engineer, but like, I haven't like built the Dragon, like, Will's on like, I'm competent enough to be able to speak engineering with founders that I talk to, and I've like built like websites and like, sure, some embedded software stuff and some like small robotics and things like that, but like, the level of complexity from that, it's like for sure way more technical than most, like, let's say VCs or hell, even most people in Silicon Valley that are even like software engineers. But, let's say your average PM at, Google, who's completely non-technical, the delta of like that to me is the same level of delta from me to like Will, let's say, right? He was the lead hardware engineer on the Crew Dragon. He was head of mission control for 8 of the cargo ISS missions. So not only has he built the spacecraft, but he's flown the spacecraft and dealt with the intensities of like, mission failure at mission control. So, extreme technical depth, both on the actual design, construction of spacecraft, but the actual like technical operations of a spacecraft, which is in some ways like just as complicated as the actual design process. Extreme sort of, extremely deep technical background in sort of building and operating spacecraft. And there's going to be critical for something like Varda, where like, space factories are in some ways an even more complicated spacecraft than, Dragon. In other ways, there's easier because there's no humans on board. But I realized that basically as, somebody in the for the CEO position, I wanted somebody that sort of had been at SpaceX and specifically on Dragon, in particular because we have a sort of reentry problem that we're trying to solve. And, the Dragon is basically the only commercial reentry vehicle that's ever been built. And so, it felt like sort of the natural group to go after, to find somebody who had left that group ideally, had left SpaceX and had entrepreneurial ambitions. And Will literally perfectly fit that.
Right.
So I did not think when I first started off in July, I remember talking to my girlfriend being like, I'm thinking about like doing this thing. I would need these like, I need the CEO that has this background and a chief scientist that has this background. But like my ability to pull that off is very unlikely. These are going to be like long conversations. There's just like no way that I pull this off in any year time frame. And then all of a sudden by like, mid-September, I felt like I was like staring down the like barrel of a shotgun where I was like, oh shit, like I found them. Right. And so I have to like, now I got to go do it. Like I can't not do it now that I found them.
Can you talk, so before we get into a little bit, I've spent the last few weeks reading about Varda, and it's fascinating, but can you talk a bit more about the ambitious vision of what Varda actually is and where the name comes from?
The way this all came about was just like a decade ago, seeing a couple companies like launch and research projects that sort of showed the promise for a variety of different like high value materials that had benefit from being manufactured outside of a gravity field.
Like
and
what?
The reason
What would be an example of that?
Let's get back to that a little bit later, and then like let me talk a little bit more about like these sort of like, let's say, ambitions of Varda and the naming. Once I sort of realized that there were these materials, the analogy that always sort of like stuck with me, and the thing that has like really captivated my mind over the past decade, is thinking about how did California, or let's say how even did San Francisco become San Francisco? It wasn't through like the government, subsidizing Lewis and Clark expeditions, or the defense industry paying for those. It was through the gold rush, and that the sort of low Earth orbit manufacturing, sort of feeling like that gold rush, where you could actually much more quickly expand humanity's reach into the stars by focusing on orbital manufacturing and establishing that supply chain. Because the scale that could get to, on the order of like, let's say, if Varda works, we could have something that's 10, 100 times larger than the International Space Station, regularly manufacturing things up there and bringing them back down. having something like that operating and commercially viable just allows for a scale of exploration into the stars that's much more viable than just trying to go directly there today, right? There's a reason why the, let's say, defense industry has never been able to, like, build an RFP for like something like an iPhone versus the commercial industry, because there's just such massive scale and continuous innovation around it. Eventually get something that, back in, 2005 would have cost like, $100 billion to have something like this, right? And so by sort of focusing on the commercialization of space, that actually significantly enables and makes everything so much cheaper, in terms of exploration. And then the actual sort of name, behind Varda, sort of originally came from. I'm not necessarily a huge Lord of the Rings fan myself, but every Founders Fund incubated company so far has been a Lord of the Rings reference, with Palantir being the I think it's like all-seeing eye, Anduril being like the sword, and then Varda is named after an elvish queen that was known for basically making the stars in the sky from the morning dew. So manufacturing stars, manufacturing in space, relatively similar ambitions. And then in terms of types of materials, there's a wide array of materials. Anything to do with high value, lightweight materials where you need to control crystals, whether they exist or the shape of the crystals in the material matters a lot. So that can be everything from semiconductors, that can be cancer drugs, that can be fiber optic cables. There are a ton of different sort of material applications. The physics of it that's maybe easiest to understand, that isn't necessarily one of those that I just mentioned, is around sort of human organ 3D printing. The reason it's sort of valuable to be outside of the gravity field is like really easy to understand in this particular use case, because the way that these types of organs get printed, and these are very sort of like, let's say, complex shapes with very thin walls. As you can imagine, if you start to do that on Earth inside of a gravity field, as you start to sort of print up, right, the way that 3D printing works is you go around and build it layer by layer. As you get like halfway up the layer of a wall, gravity effectively starts making those very thin walls flop over. And typically what we do in like metal 3D printing is you're trying to build like structures underneath to hold up those walls, and you cut those out. But it's really hard to do that with natural tissue. Versus imagine doing that sort of same physical process outside of a gravity field. As you start to print up those very thin walls, there's no gravity, there's nothing affecting it, so there's no flopping over. You can very easily sort of constrain something and hold it in a very particular shape because there's just no forces being enacted on it. And so the way that you can kind of think about Varda is like, we're a factory where the laws of physics are in our factory are completely different than every other factory on Earth, right? Every manufacturing process on Earth today is designed and predicated upon operating inside of a gravity field. And for sometimes it's beneficial, right? You want the ball to roll down the hill, helpful. But sometimes when you just want the ball to stay down at the top of the hill, irrespective of how the hill tilts, it's helpful to be outside of a gravity field.
And what does the day-to-day at Varda currently look like in order to make that more of a reality? Like, what are the building blocks that need to happen in order for that to exist?
Yeah, thankfully there's been a lot of the science that has been already sort of proven on the International Space Station over the past decade in terms of the viability of these materials. However, the International Space Station and NASA are not commercial organizations, right? NASA's explicit, goal is to further the research of space, not further the commercialization of space. And so they have no interest in turning the ISS into a large-scale factory, nor is it particularly well designed for that. And by the way, for most factories, you want them to just be fully automated and have no humans on board, since engineering for humans in space is a much more complicated problem than engineering just for a factory in space. And so what we're primarily focused on is thinking about sort of what is the infrastructure, supply chain, and logistics that are necessary, for orbital manufacturing. And so that has everything to do with the actual, spacecraft and factory that goes up there. How do the materials move about, and then how do you actually return those high-value materials back down to Earth and then eventually pick them up? All of those various, aspects of the supply chain is what we're effectively working on day to day at Varda, is, sort of testing those out on the ground, and then, starting to also test those in sort of microgravity environments here on Earth, for example, with the Vomit Comet, where you can at least use sort of brief periods of microgravity testing to, ensure those systems, and then eventually it's basically, sending up a sort of MVP, space factory.
And what would be the benefit for companies in telecommunications or pharmaceuticals? You just mentioned 3D printing, but how do they benefit from these microgravity environments?
Yeah, at the end of the day, some of these are, materials that just aren't available to be done on Earth whatsoever. So, for example, with a human heart, it's just right now we're entirely limited on the supply of human hearts from organ donors from car crashes and things like that. And so the benefit there is just significantly increasing the supply of human hearts, that the waiting lists for an artificial heart go from 9 months down to effectively a day or two, as you're just waiting for the production of your heart in space to come back down to Earth. For example, in telecommunications and the fiber optic cables, it just comes down to it's just a cheaper dollar per bit. The sort of quality of the cables you can make in space is far better than you can on Earth, and that just means cheaper internet. For semiconductors, it's just sort of higher yield.
Is that all because of this microgravity environment?
Exactly, yeah. So the thing that sometimes I think people don't realize is like the reason that you're manufacturing in space isn't for the vacuum. We can very easily simulate a vacuum down here on Earth, right? You can literally just use a pump and pump out the air, and you can create yourself a vacuum chamber. However, I could give Elon Musk, Mark Zuckerberg, and Bill Gates like $5 trillion each, and the next 2 decades if I wanted. And I just would tell each of them, like, hey, I need you to make it so that like when I drop this phone, it doesn't hit this desk right here. There's just zero chance. We are nowhere even close to being able to manipulate gravity fields, and so the only way to remove yourself from a gravity field is to go into orbit. And so there's just basically a lot of processes and manufacturing processes that benefit from the lack of gravity, and the only place where we can have no gravity is in space right now. For sure, maybe one day we'll be able to control gravity, and great, we'll move all that zero gravity manufacturing back down here on Earth. But if we're manipulating gravity fields, we'll have warp drives and wormholes and stuff like that, so we're a ways away. The other way to think about it is like we just discovered gravity waves, right? Like we just for the first time observed gravity. That's like basically going to the cavemen that just saw fire for the first time and telling them, hey, like you now need to manufacture lasers because like you need to not only observe photons, but you now need to control them. Like we're roughly there, right? We just saw photons for the first time, and now we have to manipulate them, and nobody even knows how one would do that.
And beyond that, do you intend on sourcing materials as well? I was reading the post from the asteroid mining and building the infrastructure for that. Is that something that your team intends to do?
If we succeed, we will be by far the most natural sort of company to pursue that type of material gathering or to partner with. Right now, if one were to bring an asteroid from space into orbit above Earth, even if it had very high value materials, we'd have no fucking clue what to do with it. Like, what are you going to do? Like, one, you can't bring it down and just deorbit it. You're just going to crash and create literally an asteroid crash site and potentially destroy a lot of life on Earth. Or it's like, what are you going to do? Like strap a dragon to it and then have some astronauts go out with some shovels and picks? Like we wouldn't even know what to do with asteroid materials right now, even if they were in orbit above Earth right now. Even if we had plenty of platinum, zinc, water, etc. up there, nobody would know what to do with it. However, if you have something that's 10 times the size of the ISS, orbiting Earth and regularly consuming materials, we're pretty incentivized to figure out what's the cheapest way for us to get raw materials, including water, rare earths, etc. And so we're going to be highly incentivized to rather than constantly sending it up from the very expensive deep gravity well that Earth is in, to instead bring that from outside of the gravity well, like from an asteroid, and then we'll be much more highly incentivized to go after that. And so whether it's lunar ice mining, whether it's asteroid mining, all this stuff is much more commercially viable. And this is why I talk about the way to accelerate humanity's path into the stars is by focusing on step-by-step near-term commercialization and supply chains. If we establish the low Earth orbit factories, then it makes lunar ice mining and asteroid mining much more viable. And so now VCs can invest in that. Versus if you try to go straight to asteroid mining, it just doesn't make any sense. What would one even do with an asteroid right now? Nobody would have any idea what to do. There's no customers for that, right? Or if you pitch me on lunar ice mining, I'm like, even if you had the lunar ice mine set up and you had water there, who's paying you? There's nobody there. NASA's not there. Nobody's ready for that. Versus at some point, if I've got my factory running, I'd be like, yeah, man, railgun me some water from the moon straight to my factory. Super into that.
I think what a lot of folks don't realize, which I realized while doing the reading up on this, is that there are larger pharmaceuticals that have been experimenting with this as well. So Merck and other companies have done work in this space. What sort of foundation have others set up for you to build upon, or how much of it is just building right from scratch? I mean, I know SpaceX is making it cheaper to get into orbit, but the actual building the infrastructure piece of it.
Yeah, I mean, for sure, SpaceX is a huge contributor to this, but in terms of the underlying science of the materials that have benefit from microgravity, there's been a lot of research that's been done on the ISS, including, let's say in cancer drugs. That wasn't one that, for example, I touched on earlier, but the benefit for cancer drugs is you can specify the way that a particular chemical reaction happens in a much more controlled fashion in microgravity, because you basically don't have any entropy or molecules moving around too much. There's no convection or sedimentation or anything like that, right? Imagine you have some set of molecules and some are heavier than others. On Earth, the heavier ones fall, right? Or, the other classic example is hot air rises. In space, there's no hot air rising or heavier things falling. There's no gravity. So hot air just stays in place, because why would it rise versus why would it fall, right? It just disperses kind of evenly. And so these types of chemical processes are much more easy to control, which can lead to basically much more potent, higher yields, much more effective, basically cancer drug production as an example. There's a lot of foundation across a wide variety of materials where the science has gotten to a decent level of provability, but there's still work to go from like a science project on the International Space Station that looks, cool to like, hey, Pfizer needs like, 10,000 gallons of this drug, delivered every single, year. Those are, wildly, sort of wildly different scales of problems. And so it's great that we have the like fundamental, let's say, science foundation built upon such that we can describe that to investors and show them why there's science has been significantly de-risked, but there's still like real sort of engineering that goes into, bringing that stuff to market at scale.
So talk to me about, I guess, your vision to investors. I mean, this is one of those moonshot ideas that returns a couple of funds over, but how do you convince them on the vision that this is possible, which it seems like you're doing, but even the longer term commercial viability and how much money it will take for them to get there and how many years, how do you draw out that vision for them?
Yeah, I mean, my favorite terms here are from, Josh Wolf at Lux, where like, his whole thesis was like, look, Delian, in 7 years, there are going to be a wide variety of materials that are manufactured in orbit. That's just not even a question. Like, all of the trend lines point towards it. Launch costs have gotten cheaper. These materials clearly have viability. These materials are extremely valuable to people here on Earth, and so there's going to be extreme commercial incentive to be bringing things to market. Like, whether it's you, somebody's going to be doing this. Therefore, if you start doing this now, it's almost certainly going to be you that's bringing all those things to market, because there's a lot of expertise beyond just each individual material that just goes into understanding how to do microgravity manufacturing and the supply chain and logistics of that. And the way that we sort of pitch Varda and the vision of that is like, we're the contract manufacturer for space, where ideally we're going to build in-house expertise for the first handful of materials that we're bringing to market. But over time, we'd ideally like to partner and form JVs or partner with external organizations that have more expertise in cancer drugs or human heart organs or carbon nanotubes, and instead just act as a contract manufacturer where we work with them jointly on a manufacturing process. And typically with a lot of these manufacturing and supply chains, it's not like every step needs to happen in microgravity. Typically there's some pre-processing of the material, then it's delivered to us, we do one very particular step in microgravity, and then we send it back to that ideally partner. And so ideally where there's a lot of the supply chain for some of these, including let's say cancer drugs, like I have no interest in Varda having to like get FDA clearance. What I'd much prefer to do is like work with Pfizer and say, Pfizer, you're going to deal with the design of the drug, and you're going to deal obviously with like the go to market and like getting FDA approval, etc. We're just going to focus on that one particular step where like space has a ton of benefit, and we're just going to be the like space contract manufacturer that everybody goes to. And so that's kind of the vision. Thankfully, in some ways, this is actually like much less capital intensive than a lot of the deep tech projects that have been started over the past like 5 to 6 years. Whether it's batteries, solar panels, self-driving cars, all of those sort of needing north of $1 billion of capex and R&D before you even like start to think about revenue. We're much more on the order of like 100 to $200 million before we can actually get to the point of actually potentially having significant revenues. So this isn't some sort of crazy far other thing that needs tons and tons of capital sort of to become commercially viable. And at that point, the moment that we start to prove out, hey, the space factory works, here are these materials that we're producing, this is also like very fundable by debt. It's just like, here's this vehicle, like this is now like a capital equipment purchase, much more so than it is like true R&D. And so this very rapidly I think becomes actually quite efficient on the equity dollars.
And what other talent is Will looking for at the moment to keep building this out? Does that talent not exist right now? How much more do you need?
Yeah, I mean, this is, thankfully, we don't need like a 1,000-person team to go after this like one would have like a decade ago. But for sure, there's a lot of just different engineering problems that we're going after that just need, raw horsepower. Mechanical engineers, electrical engineers, more material scientists. At some point, as we start to expand beyond our first handful of materials, we'll want sort of like a synthetic biologist that can start to think about the sort of drug production and human organ production in space. But that one's like further out. Most of like the stuff right now is just kind of traditional sort of like spacecraft engineers, mission operations, supply chain, purchasing, finance. And in some ways, like our company actually looks like quite similar to like the underlying, let's say, talent of like a Planet Labs, for example, or SpaceX. In some ways, a lot of the engineering problems that we're solving are actually quite similar. It's just with a very different lens and market approach.
Last question, because I know we're up on time, but what in 7 years from now, which is Josh's prediction of when this is working and operational and all the work you guys are doing, what does that world look like when you have this infrastructure built and you are transporting the materials and the products back and forth? What else is going on in that ecosystem? What are the other opportunities that some of the founders are building that you're also funding at Founders Fund?
Yeah, the other things that I constantly think about is just what does that low Earth orbit economy look like beyond just manufacturing? Whether it's basically like gas stations / like supply depots that are in orbit, it's a lot cheaper and easier to just send up one super large, basically gas depot, and then have sort of microsatellites, dock in with that, refuel, then dock back out. There are like the space taxis that I'm super excited about, where it's, rather than having each individual satellite have to have significant propulsion to move itself around, you basically have like space tugs that are much larger that you can dock with, and then maybe transport you to the gas station and then transport you back to, your station keeping area in orbit. I think once you have a factory that's the size of, the ISS or 10 times larger, at that point it's also much easier to think about sort of super cheap sort of space tourism. Like the idea of building a space hotel today, quite infeasible. The idea of like building a space hotel is just like one wing of our space factory, actually quite doable. And so, I think space tourism gets a lot easier once, like, if you have, flights going up and down every like week that are doing thousands and thousands of kilograms of resupply and fuel and things like that, then it's a lot easier to imagine like tacking on a couple humans as well. So I think, there's a ton that gets built out, but you have to start with this like, initial commercial use case. And the way that I sometimes think about Varda is like, Varda's doing stuff in space, but it's doing it for Earth, right? Like, we're not going to space just for sake of like building stuff in space, because like there's not that many people up there. It's not a big market yet.
Right. We're
building stuff in space for being back down on Earth. But then that's what makes the actual space ecosystem bigger and a bigger market, such that eventually, again, whether it's the low Earth orbit economy, like the sort of gas stations, like the taxis, which I think are much more near-term viable, and then further out, eventually the lunar ice mining, the asteroid mining, that type of stuff, becomes viable as well. And so, we're operating space, but for sake of improving quality of life here on Earth, since improving the quality of life here on Earth is a much larger market than doing anything in space.
Right. Delian, thank you so much. I appreciate it. This was really interesting.
Thanks for having me, Kunal. Excited to always chat about Varda with anybody that is interested.
Great.